Hey guys, so we're starting the day 4 video of lesson 7.3. So let's get started. You guys remember from days 1 and 2 that we used these two triangles in order to find mass, number of moles, and the number of particles, right? You guys remember that molar mass we can find directly from the periodic table. And Avogadro's number is a constant which never changes. And if I ever need to go from one triangle to the next, I just need to find the number of moles and then start using the next triangle because I know the number of moles, right? All right, so we're going to be using these today, but we are going to be using the concepts from day 3, where we found the molar mass of a compound, right? So days 1 and 2, we were just looking for molar masses of elements and doing all these calculations involving just elements. But today we're gonna get into compounds. So let's try this question right here. What is the mass in grams of 250 moles of oxygen gas? So let's see my key information. I know my number of moles. I know that I'm talking about O2, and I know that I am looking for my mass, right? So the first thing that I need to do is I need to find the molar mass of my compound. So right now, this is not just oxygen. So I can't just go into the periodic table, take that number, and get started with my life. I have to actually do a little bit more. So the first thing I need to do, I need to acknowledge that there are 2 oxygens here in the compound or in the molecule O2. All right, so here for oxygen, it is 16, okay? But I know that I have 2 oxygens, so it will be 2 times O, or times oxygen, equals 2 times 16 grams per mole, which is equal to 32 grams per mole, right? I'm not just going to use the 16 because this is not a pure element, this is a compound. All right, and now let's see what I'm given. I know the number of moles from the question, which is 2.50 moles. And I was able to calculate my molar mass, which is equal to 32 grams per mole. And what is my unknown? Small m is equal to question mark. Okay, so now I have my number of moles and my molar mass, and I'm looking for m. So let's figure out which triangle we want to use. We don't have particles, we have moles, but we're obviously not looking for anything in here because even the mass is not included. So I'm obviously going to be using this triangle right here. So let's see what we're looking for. We're looking for mass. So m, or little m, is equal to n times m. Remember, when 2 things are next to each other, the 2 things that are your known parts of your equation, you have to multiply them by each other. So m equals n times capital M. All right? So m equals n times molar mass. So now let's go ahead and solve this. M is equal to 2.50 moles times 32 grams per mole. So if you put this into your calculator, you will end up getting 80 grams of O2, or 80 grams of oxygen, right? Then you're going to put that in a square, because remember, we have to always put our final answer in a square so that people know what we're talking about. And perfect. All right, so that's how you start these questions. They're exactly the same as the questions we've been doing in day 1 and 2. The only difference is before you get started, you have to find the molar mass of your compound, because now we're dealing with compounds, not elements. So let's try another question here. All right, so here we're talking about calcium hydroxide. So the first thing we're going to do is we are going to go into our periodic table, and we're going to find the molar masses of each of these elements inside of our compound. So for calcium, it is right here, 40.08. 40.08 grams per mole. For oxygen, it's 16 grams per mole, and for hydrogen, it's 1.01 grams per mole. You could double check in the periodic table if all of this is right, but yeah. And now, you have to remember we have 1 calcium here, but I have 2 oxygens and 2 hydrogens, okay? That's because anything outside the brackets needs to be applied to everything inside the brackets, okay? Now let's start calculating for calcium. Calcium hydroxide. Calcium equals 2 times oxygen plus 2 times hydrogen. Let's go ahead and put all of our numbers in. So 40.08 plus 2 times 16 plus 2 times 1.01. So the molar mass is equal to 74.1 grams per mole. Okay? Now I can get started with my question. What else is given to me? I am also given the mass of the sample, and I am looking for moles. So in my unknown, I can say that N is equal to question mark because I don't know it. I can say that capital M, which is my molar mass, is 74.1 grams per mole. And I can say that my mass of my sample is 4,500 grams, which is 4.5 kilograms. All right, so now let's figure out which triangle we want to use. I think it's pretty obvious that we're going to be using this triangle because we have all 3 components and because we are looking for the number of moles, which is also inside of this triangle. All right, so N is equal to little m divided by big M, okay? It's because the triangle looks like this, N, M, capital M. All right, so N is equal to 4,500 grams divided by 74.1 grams per mole. The grams will cancel out, so you'll end up with units of moles, and your final answer after you put this into the calculator is 60.73 moles of the substance. Okay? So I don't want you guys to forget this. Make sure that you are always using the correct triangle. See what you have and what you're looking for. Decide on the triangle, make your equation, and then just calculate. Remember, with questions like these, your first step is to find the molar mass of your overall compound. All right, so let's try another question. In this question, it's going to be 2 parts. We're talking about ibuprofen. You guys know what this is. And the molar mass is given to us. So ibuprofen is an active ingredient in many non-prescription pain relievers. Its molar mass is 206.31 grams per mole. So here we're not going to actually have to calculate any of the molar mass because we just have it. So if the tablets in a bottle contain 33 grams of ibuprofen, how many moles of ibuprofen are there? So here we can see that they gave us the mass, we have the molar mass, and they're asking us to find moles. And then they ask how many molecules of ibuprofen are in the bottle. So let's start with part A. All right. So for A, we can see here that what is given to us. So we know that capital M, or molar mass, which is given right here, is 206.31 grams per mole. And then I know that my mass is 33 grams. This is because this is the number of grams, or the mass of ibuprofen that is found in one bottle of whichever type of bottle they're talking about. So M is equal to this. And what I'm looking for here, how many moles? So I know that N is equal to question mark. Okay, I don't know what it is. I've got to look for it. So now let's try to figure out which triangle we're going to be using. I can see that I have my mass, I have my molar mass, and I'm looking for moles, so I'm obviously going to use this. There's no mention of particles or anything else. So let's go here. Based on the triangle, which is N, small m, big M, remember the little m is always on top, N is equal to mass divided by molar mass. So N is equal to 33 grams divided by 206.31 grams per mole. The grams cancel each other out so that your overall compound has units of moles, but of course you don't always have to go through that process. You can just look at what you're looking for. All right, so overall you get 0.16 moles of your substance, okay, of ibuprofen that is found in your compound, or that is found in the bottle. Okay, so now we're going to go over the next question. How many molecules of ibuprofen are in the bottle? So here we are looking for number of particles. So let's see which triangle we're going to use. We're obviously going to use this because it's asking for the number of molecules. Remember, the reason we say particles in this triangle is because particles can be interpreted in many ways. We can be talking about the number of elements, we can be talking about the number of molecules or compounds. Whatever the situation is, it doesn't really matter. This triangle can be used and applied whether we're talking about elements or compounds. All right, so I can see here that it's moles equals to number of particles divided by Avogadro's number. So let's go ahead and get started with this. All right, so let's see what's given to us. So I can see, based on the triangle that I have planned on using, I've planned on using this one, N and Avogadro's number. I know that Avogadro's number is equal to 6.022 times 10 to the power 23. Now, you guys remember, sometimes it's a really good idea to figure out which triangle you're going to use before you actually start pulling out your givens and your unknowns. Otherwise, you're just going to end up with so many different things and you're not going to know what to do with them. But I know that I know Avogadro's number and I know my number of moles now. Based on the question that I answered before, I know that my number of moles is 0.16. Okay, remember all of this? So I know that N is equal to 0.16 moles. Now, with all of that, I can calculate my number of particles. Number of particles is equal to N times Avogadro's number. 0.16 moles times 6.022 times 10 to the power 23. So the number of particles is equal to 9.6 times 10 to the power 22 molecules. Right? There we go. See? Very simple. Basically exactly like what we've been doing before. Except in a lot of cases, you're just going to have to calculate the molar mass, but everything else is going to be exactly the same. All right, guys, good luck.